Hello world! Welcome to my presentation about GoF course design pattern in C#. Today we'll be talking about the state design pattern. In building an enterprise application, the state design pattern is in medium use. All source code being used here in this presentation can be downloaded with this URL. It is also available in the description below. So what is a state design pattern? State design pattern allows an object to alter its behavior when its internal state changes. The object will appear to change its class. It has three participants: the context, the state, and the concrete state. The context defines the interface of interest to its client. It maintains an instance of a concrete state subclass that defines the current state, while the state defines an interface for encapsulating the behavior associated with a particular state of the context. While the concrete state, each subclass implements a behavior associated with the state of the context. So to have a better perspective, we will see some images to make sense. So the first one is this one. We have this UML class diagram. As you can see here, we have two concrete states, A and B. It is being inherited from the state class. And you have observed here the context maintains an instance of the concrete state. So in this presentation, I will give you two examples to have a better understanding what would be a state design pattern looks like. And the first one, we have this visual example. It is a bank transaction, particularly an ATM transaction, where you withdraw and deposit cash. We will monitor the state of each balance. We will have a color code depending on your current balance. So we have this state changes conditions. If the current state is red and if the balance is greater than the upper limit, then the state is silver. If the current state is silver and if the balance is less than the lower limit, then the state is red. If the current state is silver and if the balance is greater than the upper limit, then the state is gold. If the current state is gold and if the balance is less than 0, then the state is red. If the current state is gold and if the balance is less than the lower limit, then the state is silver. So let us put these theories into a working application. Actually, I prepared already the application. Then let's have a quick run through about the application. Here we have a class diagram that I created. Okay, I'll explain to you one by one. We have this account class as a context. Okay, it has a local field of owner and a state as being defined. What is a context participant? It maintains a single, you see here, it maintains a single of the concrete state, okay, which is this one. Okay. Then we have properties for checking the balance here. Okay. Then we have also a property of state that I mentioned earlier, that we have to maintain a single instance. I mean, an instance of the concrete state class. So an account has this particular method. Okay, let's open this one. It has a constructor first that we have to set a default value. We set the owner, and the default state would be a silver state, and it has a balance of 0. Okay. Then next thing is we have a state, an abstract class. We have the following fields here: an account, a balance, an interest, a lower limit, an upper limit. Then it has also methods: a deposit, pay interest, and withdraw. Next thing is the 3 stooges. Sorry for this. These are the concrete state. We have the gold state, red state, and the silver state. Sorry for the chicken background. So these are the concrete state. It is being inherited and the state abstract, and it implements the methods being the abstract method from here, from your abstract class. You see here we have here. If you deposit, of course, you will add it to your balance. Then it will check what is the state now. Here's the condition. If you recall it from the PowerPoint presentation, if the balance is less than 0, we have a red state, and if the balance is below the lower limit, it is a silver state. We will go back to the silver state. Okay, let's go back to the other one, the red state. Okay, here, of course, pay interest. The pay interest would be balance times the interest. Then it will increment. It will be the new balance. Then it will check for the state change, and we have this condition as being identified in the PowerPoint presentation. Okay, same likewise what we have here in the red state. And by the way, actually the code is pretty much the same, and it only differs from the business logic behind it. If you can see the state change here is different from the previous one. Other those things, like of course it is common for deposit you have to add it up, but in the withdraw you have decrement value amount minus the service fee. Okay, of course when you withdraw, you don't implement an interest, to pay an interest because you're withdrawing money. Okay, this is the state, same likewise, the same method, but if we look into the implementation, it is different, particularly the state change check. Okay, so goes the theory, and let's see these things work. Hope you guys really follow me and understand what I'm trying to say, and let's run the application. Okay, yes, it runs now. So it is a state pattern. Let's press 4. Then the first example is bank transaction. Voila! Yeah. Let's open first the playground and let us see the bank transaction here for post-date pattern. Sorry for this one. I will explain to you later. But we are still in the date pattern, particularly the bank transaction. So here, let's open the application console results. Okay, here, we instantiate an account class and name the account to Juan de la Cruz. Okay, then we deposited an amount of 500. You can see here, it checks what is the current state when you deposit 500. It changes to silver state. Then what happens if we again deposited 300? It is still in the silver state. Then what happens if we deposit 550? Oh, there you go. You have a new balance there. And of course the status, the state changes from gold. I mean from silver to gold. Then pay interest is being executed after deposit. We have a new balance here. And still the status is gold. And what happens if we withdraw an amount of 2,000? You can see here the state changed to red. And the balance is 582.50 cents. Then what happens when we withdraw 1,100? It will prompt you no funds available for withdrawal because the current balance is 582.50. Then the status is red. So goes the presentation for example number 1. So let's prepare for example number 2. Let me open first the PowerPoint presentation. For example number 2, the name of the example is Prime Approval Hierarchy. Okay, if we recall our project in discrete, advanced discrete mathematics about prime. So on that example, if we recall, possible application of prime is for access rights and synchronization. Then we have a new application for the use of prime. This time we will use it for the approval hierarchy. So how this approval hierarchy works using prime. So in this example, let's say we have a purchase order. Then we will set approval hierarchy for purchase order. For the purchase order to proceed, we have to set up an approval hierarchy. Then let's say, for example, we have set a 4-person, okay, 4-person for the approval hierarchy. In order to proceed with the purchase order, this personnel should approve it first. So here how it works. Okay, each approvers will have a prime number assigned. As you recall from our prime algorithm, every new approver will assign, the next prime. Okay, the next prime. Next thing is, after assigning the prime, it will calculate the prime formula. The prime formula is the product of all of these 4 primes. 2, 3, 5, 7, that will result to 2, 10. Okay, next thing was okay. So each approver, the prime formula will be saved in the database. Then how would you identify if the approver how do we know if the approver is the current one or is the assigned approver for the purchase order? So as we recall from our prime algorithm, we have to use the modulus operator. We have to use the modulus operator. We have to get the modulus result based on the prime formula with its corresponding prime. Okay. Then if the result is 0, then he is probably an approver for this particular entry. Okay, then here's how it goes. Let's say, for example, the first approval is Ryan Dow. Once he approved the purchase order, the new prime formula will be computed. Since Ryan Dow is already approved the first hierarchy, so the remaining approvers would be Matsumoto, Rosen, and Stostrup. If you multiply this their prime, that would result to 105. Okay. The next thing, if Matsumoto approved this purchase order, again the prime formula will recompute. This is a result of the prime of Rosen and Stostrup. If you multiply this one, it would result to 35. And again, when Rosen approves the purchase order, so the next thing, the next approver would be 7, and that is Stostrup. And when Stostrup approves the purchase order, that will result to 1. Then the new prime formula is 1, meaning to say it is completed. Okay. Let me explain first to you. When Ryan Dahl approves the purchase order, the state there is started. Then the next thing is ongoing. Then when the new prime formula becomes 1, it is completed. So let's have a UML class diagram here. There you go. Here, the context is the approval, and we have the state. And the concrete state here is started, ongoing, and completed. We will be monitoring what happens to the approval hierarchy here. So we have another classes here, the model and the collection. It is not, on this example, it is part of the participant, but it is not an actual participant of the state class. It is participant on this example only. If you can see here, we have a base state, okay, because I will be using these three methods here from time to time, because it would be ugly to put repetitive code from started, from ongoing state, and completed state. So I put it in a base class, so that all these three states will just inherit to the base class, and it will use only a single instance of these methods. Okay, hope you guys will follow me, and let's see this sample interaction. So we will open again the application. We have it here. Okay, let's run the number 4, which is the state pattern. Then let's run the prime approval hierarchy. Okay, that's the result. Let me open first the Visual Studio Code. I mean the Visual Studio, so that I'll be able to explain to you how this result came out. So this one. Okay. Actually, basically, it looks to the collection of approver. Okay. We created a single instance of the collection approver. It looks to it through its model. Then, but first it instantiates the approval first. Then after that one, it looks to the approver collection. Then it takes the appropriate action. I mean, and this one, it approves the purchase order, let's say, for example. So here first we save the prime formula, which is 210, because here it's 210. Okay. Then the first approval is Ryan Dahl, which has a prime value 2. Okay. Then he approved it. Okay. Then the prime formula is recomputed because it removes Ryan Dahl from the approver, because it is Ryan Dahl had already approved the entry, so the state is started. Okay. The next thing is Yukihiro Matsumoto. His approver's prime is 3. Upon approving the entry, the prime formula is recomputed. It becomes 35. Then the state is ongoing, meaning to say the approval is in ongoing as of now. So the next thing is Guido Van Rossum. His approver's prime is 5. Since he approved the entry already, the prime formula is 7. Then the state is now ongoing state. Lastly, we have Shorturl. His approver's prime is 7, and after he approved the entry, the prime formula becomes 1, and the state is completed. So goes your state design pattern, and thank you for listening.